Hi, I was just going to explain this last part of this lesson, which has where I've put both the lots of equations together for simple harmonic motion. So the ones in blue are for when timing starts at equilibrium, and the ones in orange are for when timing starts at the end positions. And then just going a step further, looking at the equation that defines simple harmonic motion, just to draw your memories back to the very first lesson. The definition of simple harmonic motion has to do with the relationship between acceleration and displacement. So if you look at the equation for acceleration from there, acceleration is negative omega squared a sine omega t, but this a sine omega t is y. If you look at that, so then this equation actually becomes a is equal to negative omega squared y, and that is what defines simple harmonic motion. So it simply means that acceleration is proportional to displacement and that it acts in an opposite direction. The negative sign implies opposite direction. And then going again back to the very first lesson where I drew this graph that defines simple harmonic motion. This is the straight line tells you it's proportional, and the negative gradient tells you it's in the opposite direction. Now, one more step is that the gradient of this graph is actually omega squared. So if you're given this graph and you're asked to calculate angular frequency or angular speed or angular velocity, all that you have to do is find the gradient. That'll give you omega squared, and then just have to find the square root of that for omega. So that kind of concludes our lesson. I hope you understood this far, and all the best. Bye for now.